What up, party people? Got another wonderful physics problem for you here. So this one, we're shooting a bullet, and we want to know how far is it going to go. And all you really need to know to do this is the fact that you're on Earth, and you need to know the initial velocity of the gun and how far you shot it from. Thankfully, all that information is provided. So first things first, draw a picture. So here's me, I'm shooting the gun. Or I guess a vacationing Wall Street banker is. So they're shooting a gun, and the gun is going to go some distance like this. And what we're really after is, what is this distance? Okay. Um, now we know some information. I know this height. This height is 1.6 meters. I know this initial velocity is 252 meters per second. We can know the bullet velocity of guns. And we're on Earth. Okay, so this is really all we need to know. It's kind of amazing, right? How far is a bullet going to go? All you need to know is how far you shot it, how high you shot it from, and how fast you shot it. Okay? So, what we really need to know is we need to know x evaluated at some time, where this time is the time of flight. If I can evaluate this, if I can come up with some position function, x of t, and then evaluate it at this time, the time of flight, then that'll be my answer. Okay. So first things first, why don't we try and write x of t? X of t will be my initial position, 0, plus my initial velocity in the x direction, which is 252 times t, and then my acceleration in the x direction, which of course is 0. So we just get 252 times t. Okay, so now we need the time of flight. So with the time of flight, we're asking how long is the y position of this thing greater than 0? If the y position is greater than 0, then it's still in the air. So what really we want to know is, when is y of t equal to 0? That's really what we're after. So I can write y of t. Y of t equals my initial position, 1.6, plus my initial velocity in the y direction, which is 0. And then I'll get minus gt squared over 2. So I want to know, when is y of t 0? So I'm going to set this whole thing equal to 0. Now I'm going to solve for time. I will get that the time, this is really the time of flight at this point, time equals the square root of 2 times 1.6 divided by g. G is 9.8. And if you have a excellent calculator, like mine, you will get an answer of 0.57 seconds. Okay, so now we just need to evaluate my x at this time. Here it is. So x evaluated at the time of flight equals 252 times 0.57. So this bullet traveled a whopping 143.64 meters, which is just over the length of a football field, about a football field and a half. So this is a very common trend you will do. Remember, with these 2D problems, all it is two one-dimensional problems. All right? We know how to do one-dimensional problems. We've done them a bunch previously in the semester. It's just our kinematics. Now all we're doing is we're doing that twice. But the difference here kind of is that we solve for this time, t. So the time is kind of the connecting thing that connects the x and the y. We look at the y, we deal with the y on its own, and we find a time. Now we go to the x, and we evaluate the x at that time. And that's how we get our 143.64 meters. And that is your answer.